Hello, boys and girls. We're going to do a lesson today. We're doing lesson 5.5, and we're going to talk about probability as a fraction and how we look at probability, how we say it as a fraction, and also how we use it as a fraction. So I'm going to go ahead and fold my paper, and I'm doing 3 hamburger folds as usual. And I'm going to go ahead and I'm going to draw in my folds so that you can see them a little bit neater. Okay. And so the lesson we're going to do, I'm making sure my name's on my paper, and then we're doing lesson 5.5. And we're going to be going over page 217, and we're going to go all the way to, let's see, I think we're going to 222. Okay. So first we're going to look at a little bit of information from the book about probability. So I'm just here on page 217, and you can be following along in your math book too. So a spinner has 6 equal parts. When the spinner is spun once, there are 6 possible outcomes. The likelihood of landing on any one of the 6 outcomes is equal. So the chance of getting any one of the numbers is 1 out of 6, or 1/6. So when you see that fraction, this can mean either 1/6 as a fraction, or it can mean 1 out of 6. You can say it 1 out of 6. Also remember that when we see this line and we see 2 numbers above it, it also can be division as well. A favorable outcome is a result you're looking for. If you are hoping to land on 5, then 5 is the favorable outcome. So if you have your spinner here and you want to land on 5, 5 is going to be your favorable outcome. The likelihood or probability of getting a favorable outcome can be written as a fraction. Expiration station. I am loving that. Oh, fantastic. Okay, I'll be by in a minute. Okay, bye. Okay, sorry about that. Phone call in the middle of recording. No worries. Okay, so the likelihood or probability of getting a favorable outcome can be written as a fraction. Probability of a favorable outcome equals number of favorable outcomes, total number of possible outcomes. So in other words, we have a 1 in 6 chance of landing on 5, 1 out of 6, right? There are 6 total little compartments, and in order for us to land on one of them, we have a 1 out of 6 chance. So the likelihood or probability of landing on a 5 is 1 out of 6, or 1/6 if you say it like a fraction. Okay. Joe wants to land on a number less than 4. So his favorable outcomes are 1, 2, and 3. So he wants to land in the light purple area. There are 3 favorable outcomes out of 6 possible outcomes. So the probability of landing on a number less than 4 is 3 out of 6, right? Because there's 3 up above and there's 6 total. And 3, 6, if you squint your eyes, that's half is shaded, right? Half is shaded. So his probability is 1 out of 2 or 3 out of 6, okay? So we're going to do some problems with a spinner. Elena made a spinner with 8 equal parts, and she labeled each part from 1 to 8. And we're going to do problem 1. So if she has a spinner that looks like this, this is the middle right here. So we're going here to here, here to here, here to here, and here to here. Oops, I missed the middle. Let's make the middle fatter and then it will look like we went through the middle. So she has 1, 2, 3, 4, 5, 6, 7, 8. And there's a little spinner arrow that's pointed to 7. Elena made a spinner with 8 equal parts. She labeled each part from 1 to 8. How many even numbers are there? Find the probability of landing on an even number when you spin the spinner once. So let's see. We could say there are green box even numbers. So let's see. If we were to look at the spinner, we'd say 1, 2, 3, 4. So there are 4 even numbers. The probability of landing on an even number is so remember we have 4, right? And how many total spaces does Elena have? Well, she has 8. And 4 out of 8 is the same thing as 1/2, right? If we were to squint our eyes, we would see half of these shaded, right? So 1 out of 2 chances of landing on an even number. So that's a pretty good chance that she's going to land on an even number. If we were to look at the chance of her landing on 0, we would have no chances of her landing on 0 because 0 is not on here. But she has 1 out of 2 chances of an even number because she's either going to land on an even or an odd, right? So 1 out of 2. How many numbers are divisible by 3? Find the probability of landing on a number divisible by 3 when you spin the spinner once. So let's look at this. Which ones are divisible by 3? 1 isn't, 2 isn't, 3 is, 4 isn't, 5 isn't, 6 is, right? 3 times 2 equals 6. 7 isn't, 8 isn't. So we only have 3 and 6 are the 2 numbers that she can land on that would be appropriate for that. So we would say that she has, let's write in, there are blank numbers divisible by 3. And the answer there is 2, right? There are 2 numbers that are divisible by 3. The probability of landing on a number for landing on that is, so how many total does she have? 8, right? 8 is, the total number always goes on the bottom, just like it does with a fraction. And then she has 2 chances, right? So 2 out of 8. And we can simplify that by saying 1 out of 4. Just like we simplify a fraction, we divide the bottom by 2 and the top by 2. And we get 1 out of 4. So she has a 1 out of 4 chance in landing on a number that's divisible by 3. Okay? All right, now let's look at representing probability on a number line. So we're going to take a peek at page 220. The Weather Channel forecasted stormy weather on the weekend of an outdoor carnival. The probability of stormy weather was 7 out of 8. So here's our little number line. We have 0 to 1 whole. This is half. So we have 0 out of 8 is impossible. 8 out of 8 is certain. 4/8 is equally likely, right? Because it could go this way or that way. Less likely goes this way, more likely goes this way. And we're right here at 7/8. So when you write a probability as a fraction, the closer the probability of an outcome is to 1, the more likely the outcome is to occur. So the probability of rain is more likely because 7/8 is closer to 1 on the number line. Okay? So now we're going to draw this. It says find each probability as a fraction on the number line. Then describe the likelihood of each outcome as certain, impossible, less likely, more likely, or equally likely. Okay? A bag contains 2 red cubes, 3 yellow cubes, 3 blue cubes. Find each probability below when you pick 1 cube from the bag. Okay, so let's draw out the number line. I'm going to draw it across here. I hope that's not a problem for anybody. I'm going to draw it across this little lane right here. And then we'll answer the questions below. And we'll call this right here is going to be 1/2. Okay? And then we have 0. And then we have 1 whole. And 0 is also 0/8. This is 8/8. This is 4/8 is half, right? And then we have 1, 2, 3, 1, 2, 3. Because we have to have 1, 2, 3, 4. 1, 2, 3, 4. Okay, so let's list the probability of drawing a green cube. So we have, I'm going to list these up here. We have, it says we have 2 red. It says we have 3 yellow. And it says we have 3 blue. And I'm going to do this because when I see colors, it makes more sense for me to see the colors in color. All right, so we have 3 blue. We have 3 yellow. We have 2 red. Okay. So the probability of drawing a green cube. Well, guess what? There's no green in here. I see 0 green, so there's 0 out of 8. So for number 3, we're going to say 0 out of 8. The probability of drawing a yellow cube. Well, yellow, we have 3 of them, right? And we have 8 total. So that would be 3 out of 8. I can't reduce 3/8 any further. Number 5, the probability of drawing a red or yellow. So if I have red or yellow, 2 plus 3 is 5. So that would be 5 out of 8 chances. Again, I can't reduce that any further because 5 is a prime number. And number 6, the probability of drawing a red, yellow, or blue cube. Well, this would be 2 plus 3 is 5 plus 3 is 8. So I would have 8 out of 8 chances, or 1 whole chance, like 1 whole. So I would definitely pull one of those. So we're gonna use our, let's add our words that we have that are in purple in your book. So Certain, this would be certain. This would be more likely. This would be less likely. This would be impossible. Right? You're not going to pull a green cube out because there isn't one in there. Okay? Did that make sense to everybody? And you can we could plot it on here. We could say this is 3, this is 5, so it's going to be, that's why it's more likely. And then this is certain. This was our other one of impossible, right? Okay. Let's look at number 1 on page 221. Jake played a dart game at a carnival and won first place. He was asked to pick his prize from a bag that contained the names of these prizes. Okay? So, inside of his bag, he has 4 caps, 3 baseballs, 2 pairs of sneakers, 1 skateboard. Wow. I know what I'd want. I'd want the skateboard for sure. So, he was asked to pick his prize from a bag that contained the names of these prizes. So, the probability of getting a pair of sneakers. So, if he's going to get sneakers, we need to know the total, right? If we know that he's probably going to get 2 chances of sneakers, but we need to know the total, the probability. So 4 plus 3 is 7, 8, 9, 10. So he has a 2 out of 10 chance to get sneakers. But we can reduce that. We can divide each one of these, the top and the bottom, by 2, and it's going to give us a 1 out of 5 chance for sneakers. The probability of getting a baseball. Well, then he has 3 out of 10, right? Because there's 3 baseballs. You can't reduce this further because 3 is a prime number. So you would just have 3 out of 10 chances of getting baseballs. And a skateboard. The skateboard obviously is the grand prize because he would only have a 1 in 10 chance of pulling the skateboard out. Those are not good odds. Not good odds at all. Okay, let's quickly look at the next page. Okay, so we're still on this same problem, but we're going to flip over to the next page. The probability of getting a cap or a pair of sneakers. Let's do 4 up here so we don't have to flip sides. So getting a cap or sneakers, there's 4 caps, there's 2 sneakers, 4 plus 2 is 6 out of 10. And then we can reduce that. We could divide by 2 and we would get 3/5. We divide by 2 on the top and 2 on the bottom and we get 3/5. So he has a 3 out of 5 chance of getting a cap or sneakers. The next one, probability of getting a baseball or a skateboard. So baseball is 3, skateboard is 1, so we have 3 plus 1 is 4 out of 10. We can divide the top and bottom by 2, and that's going to give us 2 out of 5 for a skateboard. Crowding this in here. And baseball or baseball. Okay. And crowd in number 6. The probability of getting a football. Well, there's no football in here, so the probability is going to be 0 out of 10, right? For a football. So, on this first one, we had 2 out of 10. Is that less likely, highly likely, more likely, impossible, certain? I would probably say that this is going to be less likely, right? Three out of 10, also less likely. One out of 10 is extremely unlikely, so less likely. Caps and sneakers, 6 out of 10 or 3 out of 5 is more likely. 2 out of 5 or 4 out of 10 is, that's less than half, right? So it's less likely. This is impossible because there's no football in the bag. Okay, sorry, we have really squeezed that in there. That was not my intention. It just sort of happened. All right, so the words that you should be really familiar with are impossible, certain. Certain means it's absolutely going to happen. Less likely, more likely, or equally likely. And when you use a number line to look at the odds, it kind of helps you to figure that out. Okay, we're going to do the last few problems that are here on the bottom of the page. Find the probabilities of fraction, draw a number line, and mark a point on the line for each probability. Jake's younger sister, Shauna, came in at third place. She wanted to win a beaded bracelet. Her bag of prizes had the names of these prizes: 4 soft toys, 2 caps, and 1 beaded bracelet. So, how many total do we have? 4, 5, 6, 7. So, our little chart we're going to make on the back, let's make a number line that goes from 4, 5, 6, 7. That's an odd number of prizes. So we have 0, 1 whole, and this would probably be, if we have to have 7, that means we're going to have 1, 2, 3, 4, 5, 6. Let's make this 6. And let's carry it out a little further and make this 7. Okay, so this is going to be 1 out of 7. This is going to be 2 out of 7, 3 out of 7, 4 out of 7, 5 out of 7. This is 6 out of 7, and this is 7 out of 7. Okay? So, the probability, and let's also draw out, we have 4 soft toys. Okay, so she can get 4 soft toys. She can get 2 caps. She can get 1 beaded bracelet. Okay, so the probability of getting her favorable outcome, and she wants a beaded bracelet, right? So, what is the probability of her getting a beaded bracelet? There's only one of them. So she only has a 1 in 7 chance. We can mark it right here and say beaded bracelet. So she has a 1 out of 7 chance of getting the bracelet. That's not a very good chance. Her probability of getting a soft toy, there's 2 or 4 soft toys. So she has a 4 out of 7 chance of getting soft toys. Right? So this is, it's not impossible. She could get a, we're going to say it's less likely. This is halfway would be right here. So we could say it's more likely that she'll get a soft toy. And number 9, the probability of getting a cap or a beaded bracelet. Well, there's 2 caps, 1 beaded bracelet, so that's going to be right here. Cap and bracelet. So that's 3 out of 7. That's less likely. And number 10. The probability of getting a beaded bracelet, a cap, or a soft toy. Well, there's 4, 5, 6, 7. So that would be right here. She's going to get one of those. So it would be 7 out of 7. I'm just going to write all on there. Or 1, because 7 out of 7 is equal to 1. And that's certain. She's going to get one of those things because they're in the bag, right? And so it is likely, certain, that she will get one of those things. So I hope that this helped you to understand a little bit better about probability and to understand the meaning of the words certain, impossible, less likely, more likely, and equally likely. All right? Okie dokie. And I'm sorry we're not in class because we do all kinds of fun things where we pull things out of bags. We pull little colored squares out of bags, but we're not in class, so we can't really do that very well. I can pull things out of bags, but you guys can't at your house, so sorry about that. Anyway, I will talk to you later. See you on the flip side.